So hello friends, once again welcome to Suraj ke classes. So today the topic is what is register and what are the color lines on register. So this is actually a very simple topic. You must have seen or come across this one device which is called a register. This is present in almost every electrical and electronic circuit. Without register, you may rarely find a single circuit on face of the earth. So let's start this video and let's learn about this special device or register. So the first question is, what is register? So register means a device or equipment used to regulate or limit, or in other way you can say to reduce the flow of current. See, I'm writing here current, not voltage. So if you are a regular visitor to our channel, then you must be knowing what is the difference between the current and the voltage. So you must be able to differentiate between these two electrical quantities, and you must be knowing why I'm writing here a current, not voltage, because the resistor that is connected into the circuit is like this. The current is directly contacting with the resistor. On the other hand, if you see the voltage nothing but, you can say this is the potential difference. The potential may stay same across the circuit, but the amount of current, the amount of charges which are flowing through the resistor, okay, that may vary due to this resistance offered by the resistor. Now let's move to the another next slide. What is the material inside this resistor? How this resistor is made? So this is made of two materials. The property of resistor is not to stop the flow of current, not to be a barrier between the one end of the current from where it is passing and from the another end or to the another end. It is not the barrier, it is not stopping it at all. But what is the purpose of resistor? It is actually regulating, limiting the flow of current or flow of charges. So now the question is, what is the material inside this resistor, which is actually just providing the resistance, not totally making the current stop, but it is providing a little bit of resistance, making it hard or making it very difficult for a current to reach to its destination, or slowing down the process. So what is the material? Actually it is made of two materials, finally carbon plus ceramic. So why the carbon here? Carbon is actually the electrical conductor. It will allow the electric current to flow, but the ceramic, it is the insulator. So ceramic is having insulating properties. On the other hand, the carbon is having conducting properties. That is why these two materials are used into the resistor, okay, to make the current flow through the circuit, but at the same time limiting the amount of current. Now you must have seen on my first slide also, the resistors are always coming with these color bars or color lines. They are always coming with these color lines. Anywhere if you go, the resistors are always having this This is one of the circuit where resistor is connected. In this also you see this resistor is also having some color lines, black, red, orange, yellow, many colors. So is this design of resistor? No. This is not for the design of resistor. There is some meaning for putting all these color lines onto the resistor. And what is the meaning of this? We are going to understand in this slide. See, the color bands are divided into three categories. This is 4-band color code, this is 5-band, and this is 6-band. So not more than it. So any resistor anywhere in the world, if you are coming across, if you are reading a register, if you are having a single register in your hand, then you must be knowing that this register is coming with whether 4 color bands or 5 or 6. Okay. Now the question is how to read these color bands. Now let's take an example of single 4-band color code register. So this color coded register, the first color, okay, so the first question would be coming out in your mind that how to read, I mean, what is my first color code, what is the sequence to read these color codes, I mean, from where we should start. See, there is a gap in between these two, maybe the third and fourth, maybe the fourth or fifth, or maybe the like 6-band, 4th and 5th only. So there is a difference between these two. So whenever you find this gap more on the right side, like the gap here, more on the right side, then you must start reading the register from left to right. Here also you see the gap is more on right side. So you must start reading the register from left and go on to the right. So same way here, you must start reading the register from left and you can go along to the right. So this way you can read the register. Now what are these color lines that we are going to understand now? See, we are taking an example of this first register. There are 4 different color bands. What these color bands are representing? There is actually a chart. If you refer this chart, then you will come to know what all these registers are and how the resistance values are coming. For this 4 color band register, the value is 25 kilo ohm plus minus 5% of tolerance. For this 5-band of resistor, this is 460 kilo ohm and plus minus of 1% of tolerance. Now how these readings are coming? So the first difficulty that we had, that how to read the register from left to right or right to left, that is now clear. So now we all know that we are going to read the register from left to right, and why left to right, that we already know, we have already discussed. So now we are going to read this first register. So the first line is of red. Now refer the chart. The first line is red, then this must be 2. Okay, this must be 2. Second line is green, then the second digit is green, then it must be 5. Now see, this is very important. This is really very important. This third digit is not present on 4-band of register, but this is present on 5 and 6. 5 and 6 are equipped with the third digit, and the 4-band color code register is not coming with the third digit. So they are always into the 2-digit numbers. They are always into 2-digit numbers. So whenever you find the 5-band, then only refer this third digit table. Otherwise you are not required to refer this third digit table. So I hope this thing is clear to you now. So now for the 4-band color code, I am not going to refer this third digit. Last 2 color band or color lines are given for, one is for tolerance and one is for multiplier. See, in any register, whether it is of 4 band, 5 band or 6 band, last two color lines are always giving you the multiplier and tolerance. This case is actually exceptional. If this color band or color line is coming, then this is for temperature coefficient, and that is not present on 4 and 5 band. So there is a differentiation in between all these three. 6 band is always coming with the temperature coefficient. 5 band is not coming with the temperature coefficient, but it is coming with the third digit. And 4 band is very simple. There is no temperature coefficient, only tolerance and multiplier. So last two, if this sixth one is not coming, then these two color bands are common in 4 and 5. One is, see, multiplier and tolerance, that is coming along with every register, but only the temperature coefficient that is making you confused. But just keep in your mind that temperature coefficient is only coming in the 6 band of registers. For these two, you don't have to worry about the temperature coefficient. For these two, you have to think of only the tolerance and multiplier. So now we are here on 4 band color code register. This red is representing 2, green is representing 5, and this is for multiplier. As I already told you, 4 band registers are not offered for the third digit. So this one is orange, then multiplier is of 1k, that means 10 raised to 3. So I have to simply multiply with the 10 raised to 3, and this one is this is like golden kind of color. So this is showing you the tolerance, and now for we are referring the tolerance table. This is plus minus 5%. This is plus minus 5%. Okay, so this is coming with the tolerance of plus minus 5%. So this is how you can obtain any value of resistance. Now we are taking an example of this 6 band. So this is also simple. This is red is representing 2. This one is representing you 7, and this blue is representing you 6. Now this black is for multiplier. Black is for multiplier. Multiplier is 1 here. For black it is 1. So now 276 into 1 into the or not into, this is not required actually. So this is now again 5% of tolerance plus minus 5%, but it is having temperature coefficient of how much? This is of temperature coefficient of this one, 100 ppm. 100 ppm of temperature coefficient. Now we will discuss separately what this temperature coefficient is. See, temperature coefficient, actually if you obtain the formula for this, then this is R2 minus R1, if I'm not wrong, upon R1 T2 minus T1. Actually we are not going into this much detail of this. We will discuss it separately, but for now you just understand what this 100 ppm is. This ppm full form is parts per million. Parts per million. So this 100 ppm is 100 upon this much. 1 million means 10 lakhs. So 100 upon 10 lakh. So now you can multiply it into 10 raised to minus 6. 10 raised to minus 6. Okay. So from here you can get the value. This 1, 2, 3, 4, 5 and 6. So this is 0.0001. Okay. So this much of resistance. So what is the meaning of this parts per million is? Meaning of parts per million is for any temperature range. For any temperature range, the resistance would not vary more than this much of ohms per degree Celsius or per degree Kelvin, whatever is specified in the data sheet of the register. This is this is all for now. I hope you understood the concept of register. I hope you also understood what this resistance is and how this resistance can be calculated from just the color code lines. So I think the things are clear to you now. So if you like this video, then hit the like button, subscribe to us. Let's meet you again in some other video. Thank you so much for watching.